in science class. So let's talk about what a conditional statement is. A conditional statement is a logical statement that has a hypothesis and conclusion. So a logical statement that has a hypothesis and a conclusion. You guys remember hearing the word hypothesis and conclusion before in science classes? Maybe, possibly. All right, so I have an example of a conditional statement, and it's written in if-then form directly below this box. It says, if it is raining, then there are clouds in the sky. Well, the part that always follows your if is considered your hypothesis. So I hypothesize if it's raining outside. What's my conclusion? That there are clouds in the sky. So when you have a conditional statement written in if-then form, the part that follows the if is your hypothesis. The part that follows the then is your conclusion. Now, not all conditional statements are written in if-then form, so sometimes you're going to have to rewrite them so that they are in if-then form. So if we have this following statement, two angles are supplementary if they form a linear pair. Remember, what's our definition of a linear pair? Two angles that form a straight line, and if they form a straight line, then they have to be supplementary because they add up to 180 degrees. So this one's a little bit easy because there is already the word if in the middle of my statement. So I'm going to write that part first. So if, and then just, you want to try to get your grammar somewhat to make sense. So if two angles form a linear pair, then what are we going to conclude? Then they are supplementary. So yes, today is going to be a writing day. You'll be writing quite a bit. It means you're going to be writing all these conditional statements. Okay? So again, this one was a little bit easy because of the word if. It was already in there, so I kind of already saw where my hypothesis should be. If you're talking about the definition of something, the word that you're defining should always be your hypothesis. Okay? So if it said something like right angles measure 90 degrees, I would say if an angle is a right angle, then it measures 90 degrees. If the statement was an obtuse angle measures between 90 degrees and 180 degrees, I would say if an angle is an obtuse angle, then it measures between 90 degrees and 180. Okay? All right. So writing things in if-then form, which brings us to talking more details into our counterexample. So now we're going to think about, as a counterexample, is going to be an example that proves that the hypothesis is true, but the conclusion is false. So it's much easier to think about counterexamples when your statements are written in if-then form, because I want my counterexample to be true for the hypothesis, so true for the if part, but false for the then part. Okay, so if you got a little bit stuck on the counterexamples of last night's homework, maybe this will help a little bit. So if I have the statement that says, if the product of two numbers is even, then the two numbers must both be even. So if the product means multiply again. So if I multiply two numbers together and the product is even, So I got a number times a number that makes a product that is even. That's what's happening. Well, my conclusion is stating that these two numbers must both be even. But for me to have an appropriate counterexample, I need this part, my hypothesis needs to stay true, so this needs to be an even number, but the conclusion needs to be false. So can someone give me two numbers that would multiply to an even that are not both even? 7 and 2, what are we going with? 3 times 4. As long as one of them is odd and one of them is even. So 7 times 2, 3 times 4. That results in 14, which is an even number. So is my product of the two numbers still even? Yes. So my counterexample is true for the if, but it's false for the then. So then the two numbers must both be even. Well, here both my numbers are not even. One's even and one's odd. Okay? So that's a counterexample. All right, so let's pause there for a second. I want to practice this. The only one that you guys are going to be required to do, guys, quiet please, is the converse. Okay? So, to write a converse of a statement, it is when the hypothesis and conclusion, bless you, are switched. So if I have something written in if-then form, remember the part that comes after the if is your hypothesis, the part that comes after the then is the conclusion. All I'm going to do is literally flip the hypothesis and the conclusion, and that is what's called the converse. Okay? And you're going to have to be able to write converses for the whole rest of this course. Okay? So if I say write the converse of it, you should know what I am talking about. Okay? So let's look at this example here. It says, if a person plays a guitar, then they are a musician. So we're going to write the converse. So this is my hypothesis. This is my conclusion. And literally all we're going to do is flip-flop it. Now, yes, you do have to do some wordsmithing to make it sound, grammatically correct. Don't just literally just flip them. So let's make it sound like it makes sense. So if a person is a musician, I'm not just going to say if they are a musician, then a person plays guitar. So if a person is a musician, then they play the guitar. Okay, so we just wrote the converse. We flip-flopped the hypothesis with the conclusion. Now, is my converse true or false? That is false, right? Can someone come up with a counterexample? Shayna?
Person is a musician.
Good. And you don't have to rewrite it in if-then form. You could just say a person could play the piano. If you do write it in if-then form, that's okay. So we could say a person could play the piano. Okay. So writing a converse. You flip-flop your if and your then. Okay, so the chunk of your homework for tonight on your worksheet is going to be writing out converses. Okay, flip-flopping that. Maybe possibly finding counterexamples to your converse. Okay, and then the last part is what's called a biconditional statement. So a biconditional statement, I already did this, is, now leave yourself some space because I got a lot of stuff here, so write small. It's when the conditional statement and its converse are both true. So if the original statement is true, the converse is true, then you are able to write a biconditional statement. Now, how do we write a biconditional statement? This is how you write a biconditional statement. You're going to delete the if, then, in the conditional statement and place if and only if, and that's purposely in quotes because those are the words that you're going to be putting in your statement. So place the words if and only if between the hypothesis and conclusion. So we're literally going to delete the word if, delete the word then. So that all I will have left is the hypothesis and the conclusion. And then I'm going to input the words if and only if directly between the hypothesis and the conclusion. Not in front of the hypothesis, not at the end of the conclusion, directly in between the two. Okay? And students always mess this up. So make sure it goes directly in between. So let's look at the last example here. It says, write a biconditional statement about pentagons. Well, what do we know about pentagons? They have 5 sides. So let's first write our original. And you're probably not going to have enough lines for this, but that's okay. So if a polygon is a pentagon, then it has 5 sides. We'll call that our original statement. Is that true? Yes. What will be the converse? The converse of that would be?
If a polygon has 5 sides.
Good. If a polygon has 5 sides, then it's a pentagon. Is that true? Yeah, right? We don't call 5-sided polygons anything else. So if a polygon has 5 sides, then it's a pentagon. So since my original and my converse are true, I can now write a biconditional statement about pentagons. Now, technically, it does not matter which of the two you use. I'm going to use the original one. So I'm literally going to delete the word if, delete the word then, and what words am I going to put in between? If and only if. So I'm going to write a polygon is a pentagon if and only if it has 5 sides. Okay? So, biconditional. You take out the words if and then. What time? We're out at 8:28, right?
Yeah.
I don't know why you guys are... 28. It's new schedule today because of the advisories. I don't know why you guys are packing up. A polygon is a pentagon if and only if it has 5 sides.